So this lesson is 10.4, and I'm going to break this into two videos. Again, I'll have these notes provided to you, so I think it would be easier if you had the note sheet in front of you to draw out these diagrams and fill them in. But what we're going to be talking about is inscribed angles. So the first definition, of course, is what those are. And it is talking about an angle whose vertex is on the circle and whose sides contain chords of the circle. So here's an example of what that would look like. The vertex of the angle is on the side of the circle, and then if you notice, the sides of the angle are chords within a circle. So the chord would be running from this side of the circle to the other side, and same thing on the bottom. The intercepted arc that this inscribed angle goes through, it still lies on the interior of an inscribed angle, and it has endpoints on the angle. So what it means by it lays on the interior of the angle is it's inside this bigger angle here. And then the endpoints being on the angle itself is the arc would run from one endpoint to the other, only within the limits of the angle that is given to you. We're going to be trying to find the actual measures of these inscribed angles or intercepted arcs. So to find the measure of an inscribed angle, let's look at angle. Hold on, let's actually put the math into it here. We would be looking at angle ADB. So if you remember how to label all of our angles correctly, the first one I want to start out with is angle ADB. ADB. So this bigger angle here, that is the inscribed angle, and it is intercepting arc AB. So if I chose to extend my angle outwards, I don't have to, but if I chose to, it is intercepting arc AB. And to find the measure of the intercepted angle, it is equal to 1/2 of the intercepted arc, or in this case, it is equal to 1/2 of the measure of arc AB. So whatever the arc measure is, you cut that in half, or if whatever the inscribed angle is, you would double that. So again, this inscribed angle ADB, the measure of that angle is equal to 1/2 of arc AB. Here is just 3 examples of angles that are still considered inscribed angles. They just don't necessarily have to go through the center of the circle. They can be shifted to the right or the left of it. So notice this inscribed angle actually has a side that runs through the center. This other inscribed angle, the center of the circle is in the center of it. And the last one, the inscribed angles above the center, doesn't matter. It's just all different ways that these angles can look. So to start out finding the measures of these arcs or indicated measures is I'm going to actually start with finding the measure of, let's start with letter B first, because that goes more along, or I'm sorry, letter C, since that goes more along with the rule that we just learned up here. So if I wanted to know what is the measure, I'm just going to use this to copy and paste so I have different arc lengths. If I wanted to find the measure of angle NMP, so this inscribed angle, I'm going to take half of the arc it intercepts. So half of arc NP is equal to 50 degrees. And let's actually put the degree symbol in there. 50 degrees. For part A and part B, we're doing the opposite. I'm giving you the measure of the angle. So I know the measure of angle SRQ is equal to 90 degrees. I want to know what is the measure of the arc that it is intercepting. So I want to know what is the measure, and again, I'm just going to copy and paste some stuff so I don't have to copy it twice. I want to know what is the measure of arc STQ. You could call it SQ, I guess. I just like to have a more specific defined arc, so I'm not necessarily going backwards. And I know what the measure of STQ is because if the inscribed angle is half of the arc it intercepts, and I know the angle is 90, then I would just have to double the value of the inscribed angle to get the value of the arc. So it's 180. So the difference between A and C is in part A, I give you the inscribed angle, so you have to double it to get the arc length. In part C, I gave you the arc length, so you have to cut it in half to get the inscribed angle. And in part B, same thing as A, I'm telling you that the measure of angle ZYX is equal to 115 degrees. And if I want to find what the measure of, what's this arc here that it's intercepting? If I want to find the measure of ZWX, I would have to double the measure of the inscribed angle. So we'd be doubling 115 and get 230 degrees for the measure of that arc. So it's a lot of going back and forth. If you have the arc, you cut it in half to get the angle. If you get the angle, you double it to get the length of the arc that it intercepts. And you should also be able to tell 230 is a majority of the degrees of the circle. So that makes sense that this entire amount is taken up by that. Just another couple of ways these questions can look is, let's say I want to know what is the measure of BAC. Now I'm asking you to recall things that we learned about arc measures at the beginning of chapter 10. So going back to just central angles, if I know BOC is 132 degrees, then that means I know that arc BC is also 132 degrees. So in order to work backwards, if I know the arc is 132 degrees and I want to find this inscribed angle, I would cut 132 directly in half, and I would be getting that this inscribed angle is going to be 66 degrees. Same idea in part E. So let me just copy this stuff so I can delete things out. In part E, I know that the central angle COD is 94 degrees. So that means I need to figure out what this angle is. Now we're also looking at which angle do we want, BAC. So what would be helpful to figure out what this angle measure is, if CD is 94 degrees, so let's put that in there. We know CD is 94 degrees. We want to figure out what this arc length is because I want BAC, and BAC intercepts this arc here, BC. So if I have 94 degrees already, then that means the remaining amount from 180 goes to BC because this is on a line. So 180 minus 94 degrees is going to tell us then that arc BC is equal to 86 degrees. Now we know what the intercepted arc value is, so I'm able to figure out BAC is half of the intercepted arc of BC. So it's going to be 86 divided by 2, and we're getting 43 degrees. Please refer to this worksheet a lot because it's very helpful to let you know when to double something or cut it in half. But in short, you are cutting it a value in half if they give you the arc length and you want the angle, and you are doubling something if I give you the angle and you want to find the arc length.